So to verify the properties which we have discussed and to understand how to use, I am taking exercise 1.1 first Roman second question. So if you can observe this, you will be able to know how to use and why the need of using properties came into existence. So the given question is 2 by 5 into minus 3 by 7 minus 1 by 6 into 3 by 2 plus 1 by 14 into 2 by 5. See, you can directly solve this, but as they clearly told to use appropriate properties to find the value of this, first look. Here we have a term 2 by 5 or the rational number 2 by 5. Here at the last term also 2 by 5. Now let us recall the property of commutativity. What it actually says, a plus b is equal to b plus a. Okay. Forget about this term for some time. So minus 1 by 6 into 3 by 2 plus 1 by 14 into 2 by 5. So if we consider this one as one term and this one as second term, look, a plus b is equal to b plus a. So using this commutative property under addition a plus b is equal to b plus a, can I interchange this term to this side and this term to the other side? Yes, because if we take this whole term as a and this term as b, a plus b is equal to b plus a. I will tell you why we have to interchange this. First let us interchange. Look. So this interchange is done using the property of commutativity. We have to specify it. Look. So the first term we are not going to make any changes. 2 by 5 into minus 3 by 7. This term we will take this side and this one will bring. So plus 1 by 14 into 2 by 5. Okay, because before 1 by 14 we have plus and minus 1 by 6 into 3 by 2. Okay, just we are moving this term to this side and this term to the other side, that's all. Because look, for convenience basis only, 2 by 5, 2 by 5. Here if we take this 2 by 5, this 2 by 5 is very far to this. Hence, in order to have a clear rearrangement, by using the property of commutativity, we are interchanging this term to this side and this term to the other side of plus. So the property we have used is commutative property. Okay, commutativity. Now, look. So, 2 by 5 into minus 3 by 7 plus 1 by 14 into 2 by 5. First, sometime forget about this term. Observe carefully. 2 by 5 into minus 3 by 7 plus 1 by 14 into 2 by 5. Look. For instance, let us take this 2 by 5 as a rational number a. In this entire term, we can see this a one more time. Look, into a. Now, being the different term, I will take it as b plus 1 by 14 is also a different rational number, so I am taking it as c. Now, looking at this a into b plus c into a, are you able to get any other property of rational numbers? Yes, that is a into b plus c into a we can write as ac, because c into a into c both are same, is equal to a into b plus c. What exactly is this property? This is distributive property under addition. So using that property, that is distributive property under addition, what we are going to do is here A, that means 2 by 5 into B minus 3 by 7 plus C 1 by 14. This term you will write as it is, minus 1 by 6 into 3 by 2, using the property distributivity. Okay, distributivity or distributive property. Hope you are clear up to this point. Now the regular calculation. So we can cancel this term, 3 1s are 3 2s are. Here, as there is no chance of any cancellations, we can't do any cancellation, directly go with. So 2 by 5 we will write as it is in the brackets. LCM of 7 and 14, it is 14 minus 3 into 7. How many times is 14? 2 times. Plus 1 into 14. How many times is 14? 1 time. Minus left over term, 1 into 1 1 by 2 into 2 4. Okay. Now let us move to the next point. So 2 by 5 into minus 3 into 2 minus 6 plus 1 into 1 1 by 14 minus 1 by 4. Okay, rest of the solution I am doing here. So 2 by 5 comes as it is. Okay, bracket we can write as multiplication. Minus 6 plus 1. Minus 6 plus 1 minus 5 by 14. And the left out term minus 1 by 4. Okay, 2 1s are 2 7s are 5 1s 5 1s. The leftover terms are minus 1 by 7 minus 1 by 4. Minus 1 by 7 minus 1 by 4. For the LCM of 7 and 4, it is, it's 28. Okay, just like this. Minus 7, how many times is 28? 4 times. So minus 4 minus 4, how many times is 28? 7 times. 7 into 1, 7. So we'll get minus 4 minus 7, minus 11 by 28. Okay. So apart from the answer, what we have to understand is, by looking at the question itself, first we have to check what are the common terms. 2 by 5, 2 by 5. Is there any chance of moving this 2 by 5 term to the other side and this bringing this term to the other side? Okay, so we have to make the changes accordingly and specify the property. After that, the reason why we moved this 2 by 5 to this side is to take 2 by 5 as common. After taking common, what are the terms? Then everything will be under calculation. Hope you are clear. Now I will give you some rough idea about what are the other aspects which we have to consider for the exercise 1.1 using textbook. Please follow it. So next concept is additive inverse. So what exactly is the additive inverse? For any given rational number, what we have to add to get the result as 0. So for 2 by 5, if we add minus 2 by 8, for 2 by 8, if we add minus 2 by 8, the result is going to be 0. Hence, additive inverse of 2 by 8 is minus 2 by 8. Simply minus 5 by 9 plus 5 by 9. Minus 6 by minus 5. This minus and minus will get cancelled. We will have only 6 by 5. So what is the additive inverse of 6 by 5? Minus 6 by 5. Now, multiplicative inverse. Multiplicative inverse, as you know, for example, if we take 13, with what we have to multiply this 13 to get 1. Okay, so with what we have to multiply 1 by minus 13. Reciprocal. Simply we have to take the reciprocal of given rational number to get the multiplicative inverse of any rational number. Hope you are clear. And the next questions goes, what is the multiplicative inverse and how to check. Okay, so for the exercise 1.1, what are the important things are, we have to understand the properties and how to use them, and then the additive inverse and then the multiplicative inverse. These are all just verifications only. Okay, that means which property they have used. Okay, look, A into B is equal to B into A. What is it? It is commutative property under multiplication. Okay, so these are the important concepts pointing to the exercise 1.1. Now I am moving to the next concepts pointing to exercise 1.2. So the next concept which we are going to deal is representing a rational number on a number line. So to start with, I took exercise 1.2 first Roman first question. So represent 7 by 4 on number line. You are all quite familiar with how to draw a number line for the integers, whole numbers, natural numbers, everything. The same conditions apply for rational numbers also. So 7 by 4. Okay. So 7 by 4. This is numerator and this is denominator. This denominator 4 indicates into how many divisions we have to make for unit length. This is very important. I will tell you what exactly is unit length. So the denominator indicates into how many equal divisions a unit length has to be divided. So look, if we start writing a number line starting with 0, for example, next towards positive direction 1, 2, 3, 4. Okay, and towards negative direction -1, -2, and so on. Okay, this is the way how usually we'll represent integers on a number line. Now look, the length between 0 and 1, and the length between 1 and 2, and the length between 2 and 3, and the length between 3 and 4, the length between 0 and -1, the length between -1 and -2, we call such unit lengths. Okay, only this part 0 to 1, 1 to 2, 2 to 3, 3 to 4 we call unit length. That means whenever I say 2, 3, this we call unit length, but if I write 0, 1, 2 and I say this one as unit length, that is totally wrong. Only we have to take two numbers, the length between only two numbers, whether they may be rational numbers or integers or whole numbers, the length between two numbers we have to consider as unit length. Hope you are clear with this. So I am now moving to the next part. So we have to represent 7 by 4 on number line, and the denominator we see here is 4. So that 4 indicates into how many divisions, into how many equal parts unit length should be divided. Unit length. Okay, 0 and 1, 1 unit. You will understand why I took more than 1. So denominator is 4. That 4 indicates we have to divide this unit length into 4 equal parts. So this one 1, 2, 3, 4. Look, 1, 2, 3, 4. 4 equal spaces. Now start writing it. 0 by 4. Next 1 by 4. Next 2 by 4. Next 3 by 4. We can write 1 as 4 by 4, isn't it? Because upon cancelling this 4 and this 4, you will get 1. Now, but we need 7 by 4. We are there at 4 by 4. Again, take the denominator. And what will be the unit length after 1? It will be 2. And this 4 indicates again you have to divide this into 4 equal parts. So now we are at 4 by 4. Next 5 by 4. Next 6 by 4. Next 7 by 4. We can write 2 as 8 by 4. Isn't it? If you stop here also not a problem. But please be careful. Arrows are compulsory because they are indicating line. Once again I am repeating, look, always the denominator indicates into how many units, into how many divisions the unit length should be divided. So first unit we will find at 0 and 1. Here we have 4, so 1, 2, 3, 4 equal divisions were made. Next in between 1 and 2, look, observe here, 1, 2, 3, 4 equal divisions were made. Okay, better use squares so that it will come nice to you. So 0 by 4, because the denominator is 4 here, 1 by 4, 2 by 4, 3 by 4, 4 by 4 or 1, both are same. Next is 5 by 4, 6 by 4 and lastly 7 by 4. So our required answer is here. Okay. For example, if it is minus 7 by 4, what you will do? Okay, the number line will come reverse because negative numbers will come left to 0. So you will divide minus 1, minus 2. So 0 by 4, minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 1 you will write as minus 4 by 4. Okay, this line goes on like this. Simple. If it is plus, right. If it is minus, left of 0. Hope you are clear. Now I am moving to the next concept which is helpful for exercise 1.2. So the next concept which we are going to deal is inserting rational numbers between any two given rational numbers. So I want to give you an example. Just look. So I am taking exercise 1.2 fourth question. Find 10 rational numbers between. So 10 rational numbers between find 10 rational numbers between minus 2 by 5 and 1 by 2. Find 10 rational numbers between minus 2 by 5 and 1 by 2. Okay. For bigger numbers like this, if they ask us to find 10, 7, okay, then what we have to do is, first we have to be very clear that the denominators are different. Okay, as long as the denominators of the given rational numbers are different, it's quite impossible or not easy to find the rational numbers. Okay, for that what we have to do is first find the LCM of the denominators. 5, 2. As you know, being the prime numbers, the LCM is going to be 5 into 2, that is equal to 10. Okay, so the original rational number is minus 2 by 5 and we got the new denominator is LCM 10. By multiplying with what we will get 10 for 5, so into 2 times. 5 2s are 10. The same should be done, that means the same number should be given to numerator also. So minus 2 into 2, minus 4. Okay, next the other number is 1 by 2 and the new denominator is 10. So by multiplying 2 with 5, then only you will get 10. The same should be applied to numerator also. 1 into 5, 5. Okay, 5 by 10. Now we are done with the first problem. That means we made the denominators as same denominators. Now check. Minus 4, 5. Minus 4 plus 5. If we take the number line like this, minus 4 plus 5, in between 0, what you will have? Minus 3, minus 2, minus 1, this 0, 1, 2, 3, 4. Look, 1, 2, 3, 4, 5, 6, 7, 8. That means if we write like this, 0 by 10, 1 by 10, 2 by 10, 3 by 10, 4 by 10 and plus 5 by 10. How many rational numbers are actually required? 10. But how many we got in between minus 4 and plus 5 by 10? 1, 2, 3, 4, 5, 6, 7, 8 only. Hence, we cannot take like this. Then how to get 10 rational numbers? Look. What is the next multiple of 10? 10 table. You know it is 20. So 2 by 2. Minus 4 into 2 minus 8 by 10, sorry, 20 is the same, 2 by 2, 10 by 20. That means the original number is minus 2 by 5, the original rational number is minus 2 by 5. In order to get 10 rational numbers between, we convert it as minus 8 by 20. Similarly, 1 by 2, we converted it as 10 by 20. Hope you are clear up to here. For example, if they ask more, for example, if they ask us to find 50 rational numbers, then even we cannot find 50 rational numbers between minus 8 and plus 10. Then you will go to next multiple of 10. Here we ended up at 20. You will go to 30, 40, 50. Accordingly, you will multiply both the numerators and denominator. Hope you are clear. For example, if they ask us more, then you will multiply the same number with 3 by 3, 3 by 3, 4 by 4, 4 by 4. Like that we have to increase as long as they ask us required number of rational numbers. Hope you are clear. So now the new numbers are minus 8 by 20 and plus 10 by 20. Original numbers are minus 2 by 5 and 1 by 2. First we made the denominator same. Then as we cannot get 10 rational numbers by taking 10, we increase to 20. Okay. Now look. So minus 8 by 20 and 10 by 20. If we start writing the 10 rational numbers, therefore the 10 rational numbers is equal to, you should not take minus 8 by 20 and 10 by 20. In between 8 and 10 only we have to take. So minus 7 by 20, minus 6 by 20, minus 5 by 20, minus 4 by 20, minus 3 by 20, minus 2 by 20, minus 1 by 20, 0 by 20, 1, 2, 3, 4, 5, 6, 7, 8, 1 by 20 and 2 by 20. See, even before we go to 10 by 20, we got 10 rational numbers, and here there is no such condition that you have to take these numbers only. You can start from minus 4 and you can go to plus 9. Any 10 rational numbers you can take between minus 8 by 20 and 10 by 20. Okay, so these are the concepts in exercise 1.2. Okay, so with this we are done with the revision of first chapter. In the next we are going to look at the other chapter. Hope you are clear.